Yeah, so this game is quite interesting because this game tells you you have to get action points. AP. Alright, they give you some AP every day. And of course you get AP, which is this little strike here, that's AP indicator. So here I have action points 25, so I take 25. So you notice the blue bar up here becomes filled. So I take another one, it goes to 279. I would buy one. No, it is becoming more expensive because I'm buying two. So I just spend 500 gems to get AP. Now AP is glucose, right? AP is glucose because, or sorry, the gems is just like glucose. I am using the gems to get AP. AP is the ATP. So I could have gotten it free from this whatever here, then I have to pay. But there is also some bottles of AP that comes that could be like ketone bodies. So different, you have different forms that gives you the AP. And here you have the AP. So I have 487 AP. What could I do with it? So now you take AP, you don't make energy just to say, oh, well, I have energy, I have action points. You take energy to do things. For example, you need to go on mine goal, which is walk. You need to go to walk. So you take AP and you go there and you are walking. You don't use much to do that. So I'm not going to be bothered with this. So you want to go and get food, right? Now you have to hunt. So you have to hunt. In this case, we are hunting something called a gremlin. And that is not important, right? You are hunting it. When you click attack, you have to use 10. You have to use 10 action points. You have to use some energy to actually get to meet this thing and interact with it and, well, of course, destroy it. So you would say, so the purpose of energy is for destruction. No, well, the purpose of energy is for your survival. The purpose of energy is for your creation. Because when you look at this structure, so we're gonna have this game running there. When you look at this structure, this building here, obelisk, has to be built. Do you need AP to build the obelisk? Actually, in the game, I don't think you need AP to build the obelisk, but you need to have AP to carry out functions. So too in your body, you are not in need of glucose, you are in need of ATP. And where or how ATP comes about is the lecture for the day. So, what we do in the day, and remember, when we speak about day, we always speak about mitochondria. Mitochondria, organelles found in every cell, most organ cells and tissues. They are the ones that will take glucose and convert it into ATP. Not just glucose, not just glucose. They take a lot of other substrate and convert it into ATP. So it doesn't matter what substrate, if it's 1, 2, or 3. Once the mitochondria could consume it, it would convert it into ATP. This is the energy we need. This is the real thing here, ATP. So whether it's glucose, ketone bodies, fatty acids, whatever else we get, and the mitochondria knows what to do, it does it and make energy for a specific use. Now the high source of glucose is plants. So once you're eating plants, you're eating glucose. So you don't have to go to processed plants, which is called like cane sugar or da 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 da. Once you eat something that is a plant, you are getting glucose, and if it's fruit, you get fructose, and whatever else you get, you get. But the truth is, plants are the source of glucose. So anytime you think about source of glucose, you think mitochondria. This is going to the mitochondria. So here we put plants. Plants does not want to stay in this place called the acidic stomach because they don't have any purpose here except get a little wet by the acid. So if you have bacteria coming in, we kill it. So plants want to rush through, come to the duodenum, and then get into the small intestine here for its digestion, because we know where the pancreatic juices coming here. Okay, so plants don't want to stay here. So plants may stay here 20 to 30 minutes. Naturally, we're speaking about good plants. Now, the higher the fiber, the length of times increase, right? So if you have more fiber in your plants, raw, whole food fiber, we ain't talking about starch, we're talking about real fiber. The plants may stay here 40 minutes, right? An hour. But the fact is, the plant want to get here to get to the carbohydrates pathway of the digestion. Okay, small intestine. So what's going on here? The plants know from up here you have a little bit of enzyme amylase here in your mouth. The plants, when being eaten, the glucose molecules already tell the tongue and the other sensors in the cheeks and also the sensors in the teeth, send the message up to the brain, and the brain send the message down to the acidic stomach to say, don't get too acidic. That should be pH 1 or 2. That is what the stomach should be doing. But when the plants go down there, the acid that is there does it work, but it does not allow the little bit of acids to come from the gastric walls. And once it reaches down here and it detects itself being that, most signal goes back up to the brain, and say, yes, you're correct. We realize why. And less acid gets produced. Now imagine doing this for a pretty long time, a week, 6 days, 7 days, a week. You're basically train your brain to not, or train your stomach, we say the stomach, but it's really the brain, between the brain and the stomach, to not produce acid, because what we are putting in is a set of plants which would be digested to glucose, which does not need the acidic stomach so much for many functions. It needs really to sterilize the food, yes, but you could do that without the acidic stomach anyhow. So down here is where the plants get digested, of course, in the small intestine. Okay, so now we know that, we know the plants digest, and of course what is coming, and stay with me for that point. What is actually coming out of the plant is not a piece of plant, but a molecule of glucose, or a molecule of fructose, or the water soluble vitamin C, some other vitamin B's, blah blah blah, and they go into this portal vein up to the liver. So we get a lot of glucose, some vitamin C to come to buffer it in the cells, some other stuff comes from the plants. But you have to start thinking it is here the digestion takes place, small intestine digestion, glucose, whatever vitamin C it could pull out from this, whatever. Funny enough, when you look at this, you start realizing where some of our troubles lie. We who are on a plant-based diet does not understand this entrapment here, this entrapment called the LES and the pyloric splinter, that's the lower esophageal splinter following the oesophagus here, and the pyloric splinter. There are two trapdoors, two enclosures, two valves, they say. These valves literally closes when the stomach is pH 1 or 2. They shut from the inside out because the acid in the stomach has become so high, so acidic, pH 1 or 2, very acidic. They would not risk the human, so they close themselves shut, and whatever is shut inside here stays and gets acidified. So now let me just rub this off and show you something. Take a next page. Let's take a next page. So in your acidic stomach, I call it the bottle, I just draw it like that. In your acidic stomach, if you eat a plant such as, let's say, quinoa, and it's not fermented, I wouldn't use tofu, because tofu is already fermented, which means you already did a lot of acidification process to extract the amino acids. So that's why tofu is really a good source of protein on a plant-based diet. But if you eat quinoa by just cooking it, and you don't do support for getting your stomach to be acid, you may just be getting more or less the same kickback from quinoa, because you did not add something to help either the stomach be acidic or help the food to be very acidic. So let's look at what's happening here. If you add an egg, if you put an egg in your stomach, you eat the egg, comes in your stomach, whatever, and this egg now has fats in it, fatty acid and fat. What happens? The stomach starts throwing out more and more acid, right? Throwing out more and more acid. 1 hour after, you're still seeing acid flowing from the gastric juices in the gastric walls. Wow! Because of the fats present. Now let's look at the same scenario now, but let's look at it now with a lean piece of meat, like what's a lean piece of meat? Like chicken. I don't eat chicken for my own reasons. So you eat a piece of chicken. So let's get a color for chicken. I do have my daughter here, she is the color girl. Okay, so let's get a piece of chicken. The lean piece of chicken. Chicken is lean, chicken does not have fat. So you eat a piece of chicken, you well chew it up, it comes down into the stomach. What you would notice is that the chicken itself because it is a high what is called dietary protein. Notice we are not using, I don't like to use the word protein, but it's from the diet, meat. The chicken would cause the acid, the pH level to be 1 or 2, but for a short release. That is what is called protein sources. They cause acid to increase, but for a short time. I can't, let's just say 30 minutes. I can't really give you this because I don't know the science. But once you tie the fat with the lean protein, apparently this whole place here starts to become very acidic. And of course, once it becomes acidic, what do you think it does? It closes the valve up here called the lower esophageal sphincter, the LES, and it closes the pyloric sphincter valve, pyloric sphincter valve. It locks them from the inside out until all these things become so soaked in the acid and denatured and uncoiled. Pepsin and intrinsic factor comes up, and all the other enzymes in the acidic environment comes up and extract the minerals, extract the vitamin B, extract the amino acids, or break it down into polypeptides, and then things start to weaken down now. So the pH moves down maybe to pH 4, pH 5, and that's when the openings here start to work again. Well, when I say openings start to work again, that's when here the pyloric sphincter would open and allow one bolus of food to come out ever so often. One bolus of food which is not so highly acidic, not 1 pH 1 or 2. It should be maybe pH 3.5, pH 4, somewhere around there. That comes out now into the duodenum where the bile comes from the gallbladder and wets it here to create that nice acid neutralization process, but also for the fats to really be broken apart. So now we know, or we start to think, or we start to realize what's going on in his stomach. We are saying to ourselves, presence of fats with lean protein allows for a deeper, longer lasting effects of acidification onto the meat. Now you might say, well, I'm a plant-based eater, so I don't care about that. Let's get back to our quinoa story. The same thing could happen with quinoa in your stomach. You may be eating a protein-based plant like quinoa, because it would be a lot of carbs if you don't follow this lesson here. It's a lot of carbs too. So the quinoa comes down, but the quinoa is very glucocentric. So what does it want to do? It wants to leave. It wants to leave because the pH is not, that pH in the stomach is not 1 or 2. It is, pH is weak because quinoa is a plant. So when you add the quinoa plus an egg, or you put the egg first, or if you don't want to eat eggs, you might say coconut oil, avocado, which is a healthy fat from plant, or some kind of nuts like walnuts, not any nut, but walnuts. There are many other good seed oils, but I would only name those that I know: coconut oil, avocado oil, maybe walnuts, I don't know. And you say, well, don't eat an egg, but you're eating those things. If you eat piece of fish, fatty fish, you might say, oh, I don't eating that. Sardine, you don't eating that. Okay. But egg is like top of the line. But you have these fats, you add them in with the quinoa. And when I say add them in, we ain't talking about drizzling a little bit of olive oil or a little coconut oil. No. We're talking about adding them into the mixture. So in our historical behavior with our grandparents, when we know we're cooking peas, we would add coconut milk, which is gonna become oil. You would see it when you cook it. What would that have done? That would have caused the peas to stay in here for a longer period of time. Now, this would have caused the peas to stay here and get soaked in the acid, because the oils or the fats in the oils triggers a longer amount of flow of gastric juices, which is acidic. The gastric acidic juices, HCl, comes out and flows and holds the peas inside your acidic stomach, so you get a good soak in the acidic environment here, and that allows you to get more of the amino acids from the peas. Now, of course, we have a problem here because peas does not have all the 8 or 9 essential amino acids. So you still have to figure out where you're getting the missing 1 or 2 from the peas. And that is why it is important for us to open our minds and learn these things about essential amino acids and not protein, because that's what will be in the essential amino acids. So when we add the peas like lentils plus the rice, we know we get methionine from the rice and we get a complete protein source with this. But throwing the coconut oil into this makes it get a better opportunity for success in the digestive process here to really extract the methionine and the other essential amino acids from the peas and rice, because we added the oil or the fats when you're on a plant-based diet. Same thing would apply for quinoa. Quinoa is said to be also having all the 8 or 9 essential amino acids. So for quinoa, having something with fats gives us the opportunity to maximize on the quinoa here. I would even add, even though you're doing tofu, it may be the same thing. I'm not into those things, so I don't know how people cook tofu or prepare tofu when they are eating it. But for those who eating eggs with tofu, they are on a, getting good protein, I guess, from amino acids from that plant-based protein source. So whatever you are looking for your protein source from a plant, you have to remember, let's go back to the egg and say, oh, so this part is the 8 or 9 essential amino acids coming from the egg. That's what makes eggs so good. We have we have things like selenium and other minerals. We have other things here like fatty acids, fats, right? Fatty acids and fats are kind of different when we talk about it on these videos here. And so when we learn that, we start asking ourselves, even though I put coconut oil for my fatty acids to do this here, I still have to find out what am I missing from a mineral point of view and substitute it with things like supplement, like zinc and stuff. Substitute it. Zinc should be coming from plant, so zinc is a daytime thing. It should be coming from plant, but we will talk about that the next time. So now you understand this. You start saying to yourself, let me figure out how my life runs based upon my budget, my kind of food style, but at least the principles remains the same. If you enjoyed this video and you understand what we are trying to achieve here in terms of getting you to understand just the rudimentaries of how you prepare so that you get the most out of your stomach as compared the most out of your small intestine, which is carbohydrates, which is glucose, we want to thank you for viewing, but we also want to leave you with this great admonition. Remember our rule says plants equal glucose. Animals, when digested, equal when digested. When that equal here means when digested. When animal flesh or meat is digested, you don't get meat, you don't get protein, you get amino. So when digested is for the next time. If you are interested in more of this, please ask yourself, do you own the Trio protocol, and do you have a clear idea of what the Trio protocol is informing you about? Thank you for viewing and hope you have a wonderful day.